Very good evening to all participants and welcome you for day 3 on bootcamp on STAAD Pro. So today we are going to discuss the rest of the topics that is on dynamic inputs, how we are going to add dynamic inputs to the model, and we are going to discuss some examples that are related to that, adding a seismic wave flows, right? So let's see for day 3, what are the topics which you are going to come across. So first of all, we are going to discuss about the most two important parameters. So moment release and grouping. So I have already shared you the reading material today in well advanced to you. Just you want to have a go through it, right? So why I have shared that is mainly is you can have an idea what we are going to do today. So parallelly you can see that notes what I have given to you. Certain examples I have shared to you how you are going to do this grouping and also how we are going to do this moment release and what is the concept of moment release and why it is required. And further we are going to discuss on the topic that is on seismic input and analysis, how we are going to use the IS 1893 codebook and how you want to do that inputs in the model. So that too is based on the codebook input. And finally we have a load combinations, some 5 set of load combinations. So 5 basic load combination we are going to discuss today. So these are the topics today we are going to discuss. And first part which we are going to discuss on today is on moment release. So what is the concept of moment release? What is the use of moment release basically? Or you are hearing for the first time, might be a few students hearing what is the concept of moment release. So what is this moment release? Basically it means, so first of all you should understand the concept of a primary beam and secondary beam. So what is called a primary beam and what is called secondary beam? So this concept is important. So when you say this as a primary beam, when you talk about primary beam, so that is basically a beam which is going to rest between two column head. So this is called a primary beam. So where the beam is resting on the column head, right? So this is resting on the column head. So same way, parallelly, there is another beam. So there is a column. So this is a structure, right? So this is also a beam rested on a column. Now this is also called as primary beam. So we'll put it as PB. So don't take plinth beam. Here it is called as primary beam in this part. Now I'm going to connect this also. Right. So this makes my structure. So I have 4 primary beams where it is traveling on column to column head. Now, when you talk about the moment, the concept of moment, what happened? We know that we are designing as a fixed supports. So what we do, so we see that the beam and the column is going to have a rotation. There is a moment we are going to get that point. So at that point we are going to get 2 moments. One is the moment which is coming from your beam. One is the moment coming from the column. So I'm taking as MB and MC. So moment from the beam and moment from column. So which is going to carry out at this particular junction, either of these junctions, the moment is going to carry out. Now it is the same for all the cases wherever the joint is coming. So all the beam column joint is going to carry a moment connections. Now what is this moment release and where it is going to get affected in the building? Right. So basically where this moment, secondary moment is going to come here, it is on a secondary beam. Now what is this secondary beam? When a beam is resting over the primary beam. So there is no column face here. So there is no column connections. So the beam is resting on the primary beam. So what happened here at this particular junction, at this particular joint or here, the moment will be exceeding or it will be excess. So moment will be excess. So the load, the self weight, even though this is not carrying any primary load or any other part, it is carrying only the self weight. Imagine that is carrying only the self weight of the beam. Even though the self weight of the beam is going to create some extra moment at this particular point. So what happened? The member gets overstress and it will get more beam, more moment at that particular point. So we bring a concept called moment release. So we need to release this moment for this secondary beam at the starting point and even at the end point. So we need to release this moment. It is like something called a sugar patient. You cannot give more chocolates. So what happened? It will get spoil that person, right? So same way. So when there is some kind of issues here, we cannot overload this secondary beam. So as simple example. So the chocolate should not be given to the sugar patients. So it should be distributed to some other person who is not having that effect. So same way, the structure is also taken care how you want to do this analysis. So this secondary beam is creating a moment here. It should be released. That is called as moment release, right? So I will show you in a model also how this is working in a practically how it is going to done. And second thing, at the same manner, when you have a cantilever beam, a cantilever beam. So now let's talk about cantilever beam. So what this cantilever beam is going to do? Same action. So it is also going to create an extra moment, but where? That is a question. So example, your balcony slab. So you have your terrace or some kind of balcony area. So you have some projection here. So let us take this as a balcony now. I'm writing a small cantilever beam here. So now what happens? So let me change the diagram. So it will make you confused. So let me erase it. I'll draw again. Now we are going to discuss on the cantilever part. Right. So now I have a balcony here. Suppose this is the columns over here. And here is one small column. Now I'm going to bring a cantilever beam here. So this is going to be acting as a balcony area or corridor area. So this too is acting as a cantilever beam. CB stands for cantilever beam. And this is a beam which is resting on the portion where the slab is going to rest on this portion. Now the same concept, the moment release. Now the moment release will act on the end portion, on end portions, not on the beginning portion, because this is a start portions. So there is a column, so it will take care. At the end portion, there is no column. The beam is projected like this. The beam is projected like this. So what happened? The overturning moments will be there. So there is a failure at this particular joints. So we need to release that moment at this particular point. So the same case here. Right. So this is the concept of moment release. So why we are doing this moment release in cases. Apart from this secondary beam and primer, that is cantilever beam, we also work this for pre-stressed concrete. Wherever the pre-stressed concretes are there or panel members which you are designing at the site. So we need to release this moment. Why? You're bringing a precast wall. Suppose you have a precast walls or prefabricated wall structures. Okay, so you're bringing a prefabricated structures and you're going to fix in the building somewhere else, some walls or some kind of shear walls, prefabricated shear walls. You're going to come and connect with the building. So what happened? So at that time, we need to release the structure. So wherever the connection is going to come here and you're going to connect some prefabricated elements, so that should be released. So what happened if you're not releasing, it will be overstress. So that will create a more stress failure on this part. So what happened? Ultimately, we will be keep on increasing the size of the beam. So we will be iterating the sizes of the beam from 350, then you will jump to 400, then you will jump to 450, you will not get any results. Again, you will jump to 700 mm beam size. So you will not get any results. So still the stresses will be more there. So certain cases when you deal with the practical field, so we need to release this moment where there is a chances we need to release that secondary moments. Now, next we are going to move to the groupings. So before going grouping, I'll show you a sample of moment release. So you can see that in under command box, member specifications, and you can see the release. So once you keep on that part, it will ask you where you want to release the moment. So you need to release all the moments, all three directions, X, Y, and Z directions. So you need to release this moment at start point as well as the end point. So once you select, it will ask you assign to the selected members or selected beams, it will ask you. So you can keep on assign so that it will be released at start point. And repeat the same, you need to select for the end also, then release again, and it will be getting that. So, but don't release the force. So this is a force. We should not touch this part. So this is a reaction. So we should not touch the reactions. And this K is your stiffness. So we should not deal with the stiffness. So stiffness of the member will be taken care by the sizes and the grades which you are using. So that will be taken care by the design automatically. So only thing we need to bother on the moment, secondary moment, which is induced in the connections. So now you can see the model here. So this model shows you without release. So this is your secondary beam. So there is no column face here. So there is no column here. You can see that clearly. So what happened due to that point? So your extra moment is coming here. So you can see that 5.4 and 4.79. It's creating, even though I'm getting in 1.5 dead load, live load moments. So you can check in both the directions, Z and Y directions. So you see that there is an extra moment which is going to create at both the points, at the start or end. So you can see either this is the start or these are the end point. You can see that. Now let's see, I'm going to release that moment. So what happens here? So I release the moment at both the directions. You can see small circle head is available there. So once I release the moment, you can see on the picture, so there is no extra moment is carried on the part of the beam. So the beam is normal now. So you can see that is 0. So same way for this end also, you can just scroll it. You can see on for other side, that will be 0. So in the picture also, it's clear here. So that the moment is distributed. So the moments are redistributed to the columns here. So it will not have any effects in the building design. So this concept is very, very important when you go for design field. And second, you can see this effect. And one more note I want to keep here is when you make a beam connection. So number of students are doing this mistake when I see some students' projects. So there are certain failures are coming. The reason is they are making this connection like this. So you can see this is as one particular beam and this is one beam. So they'll make another beam connection from here to here. And then they will release the moment and they will say the moment is not released. It is showing some moment value there. So this concept is totally wrong. The mistake is if you are going to consider this as a one particular beam. So this is one member. This is considered as a one member. And this is considered as a second member. So here what you're doing, you're breaking the members. So this is one member, this is second member, this is third member, and this is fourth member. So the moment is not distributed properly here. So you're breaking the elements and your moment is where it will go. It will not go anywhere. So your structure will fail here only. So please don't do this mistake. So when you add a beam, be careful. If you're going to design as a single member, so select from start to end. Until or unless it is necessary that you're going to break due to length, like 5 meter span. So suppose this is 5 meter span, this is 5 meter span, then add one column bit. So you can add some column in between. So in such case, no need to release there. So it depends on the geometry, what are the sizes you're going to add that, right? So next part which you want to know is on grouping, column groupings. So why grouping is important? Now imagine I'm going to work on a hotel building or a restaurant building. Okay, G+6 story building. I have a G+6 story building. So there are number of columns are going to come on the building plans. So for all the beams and columns, I want to do the detailing. So detailing, if you will be studying in RCC. So when you go for RCC design, you will start doing the detailing work. So when you start doing the detailing, you will get number of columns. Say suppose detailing a structural designer is going to do a design for 1,000 column or 1,000 plus column, which is not possible. So we can't do for 1,000 plus or do all the detailing for it. So what we are going to do as a structural engineer, we are going to do that as called groupings. So what is this group? So we are going to combine the columns which are going to get similar kind of axial loads. So you can see this figure. So as we discussed in day 1 and day 2, certain brick wall load, how we distribute the dead load and slab loads for your building. So I'm just representing a brick wall loads pattern, how we need to represent in the auditing or structural auditing or when you submit to the clients. So we need to show with different color pens, green color or red colors or blue color. So we make different kind of representations of the dead loads. So here I have showed everything in a one single sheet, or else we need to prepare a separate documents separately for dead loads, separately for live loads, and etc. Right. So now once this is done, you can see the certain column heads which is going to be here. So how we want to group this? So if you give a number, you can see that initially before grouping. So this is before grouping. So before grouping, I did the model. I have applied my loads. Everything is done. Analysis is done. I got my all the axial loads with respect to 1.5 dead load plus live load. Now here I have just round off figures. So 187 means I have taken 190. 233 means 240. I have just round off to the near figures. Now after rounding off these figures, you need to see a rule here. So what the rule says for grouping is, first your column size and load should be similar. Value should be similar. Example, you're having a size of 300 by 325 mm size of column, and you're getting a load value, say suppose 190 kilonewton, and I have a same size, suppose 300 by say suppose 325. Now my load on this particular column is going to exit like suppose 240. So I cannot group because this is more variations are there. It is exiting more than 5%, I can say. So I can't group this because here it is 190 and here it is 240 or 270. Even you take 270, let it be bigger size. So I can't do the grouping here. One thing. Second thing which you want to understand is the same column size, right? Sorry, the same load. So I'm going to take the same load, 190 kilonewton, but my size is not the same. So size is, let us say 230 by 300. But I have load is same. So same load value. I can group it or not? No, I can't group this because the column sizes are varying here. Column sizes are varying here. So this rule is not possible here. So the grouping says that your column size and your load should be similar. If it is having any variations in the size or in the variations in the load value, then don't do the grouping, right? So now with that concept, now we are going to see this model. So what we are going to see in this model is, so I have grouped the columns. So I have 8 columns. So totally I got around 8 columns in this model. So various round off values are there. So certain values are starting 160, 190, 240 like this. So finally what I'm going to do is I'll just look into close and I see where are the columns are coming. So given the number, as yesterday I said, go in order wise. So from the top left side corner, C1, C2, C3, C4, C5, C6, C7, C8. So out of that 8 column, I have shortlisted to 4 columns. So I will do the design. So I will do the design of column only for 4 numbers, not for 8 numbers. So just design 4 columns. I will not do for 8 columns. So because the loads are similar, same sizes I have taken, so I'll just do for 4 column only. So my time is saved here. Second thing, you can see the loads. So where the loads are distributed. So how it is grouped. So C1 160, C2 190, C3 240 and 260. So you may have a question. So how I can do this? So it will come in practice only. But general rule, take that lesser, you should be around 5% variations. Don't cross this. Suppose you have 160 and you have some, say suppose 175. Can I group? Yes, you can group. So check whether it is within 5%, you can group it. You can group this also around 170. So bring this in 170. So you can group the column under 175 kilonewton rather than 160. It is safe. But please do not group a column which is having 160 kilonewton value and which is having 600 kilonewton. Don't group it because here is a vast variations in the values. So we should not group it. Right. Another same says 160 you have. Another thing is you have less than 160. Suppose 135 kilonewton. Can I group this to this? No, you cannot group to this. So you should bring this to this part. So this can be grouped. So 135 will bring in the family of 160 kilonewton. So like this, we need to do the practice. So how you get this is after complete analysis, you can use a node cursor, which I shared in your reading material. You can select one column and you can see 1.5 dead load. What are the loads value? Axial load is coming. So that too in FY direction, only in FY direction. And if you need to know the moment for this, you can get for mx and mz biaxial moments. We can design the columns. Right. So this is the first part which we have discussed for grouping and your specification member release. The next part which you are going to go for is seismic calculations. So the detailed calculation is showing here. So how we want to design the seismic calculations. So we can take any imaginary zone. So here I have taken 4th zone and Z is 0.24. So those who are not studied a seismic calculation yet. So this part will be a challenge for you. But those who are already aware about the seismic design, so you might be aware about the terms and technology, right? So for the freshers who is seeing the STAAD Pro for the very first time and the seismic inputs for the very first time, the 4 notable things which you want to know is a zone. One is the zone, which zone you are working. So for different countries, people from abroad are also attending the sessions. So according to your code, you can use some British standards or American codes which is followed in your country. So you can take that and you want to see your country or city, which location it is there. So you need to identify first as zone. So which zone and what are the seismic value. So that is shown here as Z. So that zone value, what are you getting as seismic inputs. And then you need to see the soil type. What is your soil type? Hard rock stratum or medium or any clay data is available or not. So you need to fix that soil data. And then your response reduction factor. What is this response reduction factor? So when a seismic waves are coming to your building, so when the seismic waves are coming from the ground, some wave vibration is coming. So how this vibration is going to observe in your building. So at what time of second you're going to feel it. So how that is recorded or how the response is recorded by the system. So that is called dynamic inputs. So we have number of methods and analysis procedure to determine this vibration. So one such as your table, shake table vibrations. We can do from shake table vibrations, how you want to get your dynamic inputs when some earthquake data is coming. So you can do that. So again, for a linear and non-linear part, we have like time history method, response spectrum and pushover analysis, or again, we have some detailed part for analysis. And here we are going to talk only on the response factor, that is OMRF. So ordinary moment resisting frame. So moment resisting frame. So that is called how you want to resist your building from the vibrations. So suppose I have a frame here. Some load is some seismic lateral forces are coming, or either let's say wind or seismic. So there is going to be certain displacement in the frame. So I want to resist this displacements. So how I want to resist this displacement? Either I can go for shear wall or I can go for bracing. So you might be aware about shear wall. So one such for resisting your forces, lateral forces, or your bracings, certain kind of K bracings or knee bracings. We have different types of bracing element, or viscous dampers. We have certain kind of hydraulic dampers which can resist your displacements. So that is a higher end, what kind of damping systems you are going to use that can be kept here. So after the zone, the next part which you want to know is your dimensions of the building. After zone, those are starting for first time, you can go for the dimensions of the building. So the dimension of building is both X and Z direction, total dimensions starting to end. So irregular geometry, let us say any irregular geometry, whatever the size or geometry shape, so X to Z shape. So you need to take from X to Z. So consider that shape dimension and then total height from the ground level. So what is your height of the building? So total height of the building from ground. So if some course there is a basement, so you need to consider certain cases, we need to take the basement height also. Certain building does not have a basement, so we can take from ground level what are the total height of the building. So with that data, we come to know what is your X direction and Z direction. So in STAAD Pro, sorry, I gone here, it is Y direction. So let us say that is I have replaced here as Y. Okay. So due to this is a different software, right? So we can take that as Z here. I'll just replace that Z. So what are the total dimensions of the building? So you need to take in X direction and Z directions, both the directions plan. So what is my X dimension totally? and what is my Z dimension total. And then you need to calculate this formula, that is your acceleration time, at what moment the earthquakes are is to be recorded. So that is your acceleration time. So we calculate that with without brick wall and with brick wall. Two concepts are there. I have shared the code book. So without brick wall and with brick infills. So this is with brick infills. Certain case you have some frames. So you need to calculate this part. So here you can see this D. So this is a dimension in X, dimension in Z. So you calculate your acceleration time with respect to total height of the building. And then similar way we have calculated the dead loads. Whatever you have calculated, the same can be kept for this part. We're going to take these values in the software. So we are going to incorporate these values in the software part. And then the third part which you want to know is on the load calculation, that is load combinations. So these are the 5 basic set of load combination. So you can take this 5 basic load combinations. So whatever the model you're creating, so the building is going to deflect either in the negative X direction or negative Z direction or positive direction. So we don't know which direction the building is going to go ahead. So suppose this is a building, so it's going to get vibrated. So when the vibration is there, the building may collapse in this direction or building may collapse in other directions, suppose on opposite side. So we don't know, we can't judge it. So we can find out where the maximum failures are coming with this 5 basic idea. Apart from this 5 basic idea, the number of students do one basic mistake. So without understanding the basics, they just simply fall to auto load combinations. So number of students I have seen in teaching, so they go for auto load combination. They don't know what is a combination at all. So just they go and jump into auto load combination, seeing some YouTube videos or some other part, they jump directly and go and fall into auto load combination. So please understand what is that load combination is. So this load combination will do the iterations. So certain kind of iteration like 1.2 times factors or 1.2 again 1.5 and 0.9 dead load combinations. So number of combinations are there, near about 23 to 25 combinations are there when you run auto load combinations. So we don't want that 23 or 25 load combinations which is there. So if you're going to start a basic level, this 5 is more than sufficient for your seismic analysis. So you can go with this 5 basic part, right? So another one important part, so the terrace live loads, what are the live loads you're going to incorporate? So that is if it is increasing more than that 3 kilonewton per meter square, so 25% reduction should be done. So more than 3, that is 50% reduction should be given. Right, so I'll explain you all this part in the code books. So these are certain important part which you need to consider in the calculation of seismic. Now I'm just shifting to the next part in the STAAD Pro. So I'm just sharing my screen there. I'll discuss all this part quickly there. Okay, so I hope the screen is visible now. Right, okay. So you can see this first model which we are discussing on the moment release. So this is a model without moment release. So this is your secondary beam. So when we see that particular point, so you can see this. So what are the load combinations you're getting? So finally you can see this bending moment for this particular beam. So how it is going to get failure. So you can see this moment are generated here, 5.48 and 4.78 here. The same model, which is same model with every details is same, all the loading, everything is correct. So I have created a with release concept. So with release concept. So when you see this model, so this model is run with moment release concept. So click on that particular part and you can see that again, you can see, so nothing is available there. So it will be 0. So you can see that is 0 here. So by this way, the stresses on this particular part is released. Even though the beam is not having any other dead loads, only self weight it is having. So I'm not giving any extra load on this part. So even the parapet load which you see on other case, so here you can see some kind of parapet cases are there. So when you see this case, so here you can see this parapet wall loadings. So some dead load cases are present. So in such case, we need to release that part also. Then secondly, you are going to discuss on the supports. So today I discussing on the supports. So I have shared you the files. So this is your day 3 file. So grouping and member release I have discussed. The next is your supports. So coming to supports, you're already aware about fixed supports. Normally all buildings we go for fixed supports. But when you go for pinned, certain cases where you want to give a pinned support, especially in the truss analysis. So we go for pinned supports. So there is only Fx, Fy, Fz, that is the restraints over there. So first two cases no problems at all. So pinned and fixed you can directly see on the STAAD Pro when you click on supports. So when you click on create support, it's easy to identify fixed supports and pinned support. But my question is I need a roller support. I need a roller support. So how I can prefer? So roller supports are fixed, but so which axis you are going to apply? Sorry, I have made a drawing here, so please update it. So it should be a roller support. I made a mistake here. Please update in your drawing. So right, so roller support if you have, that is Fx and Mx, Mz should be released. So that should be restrained. So you need to put a tick mark on your STAAD Pro. So where you have or support enforced but. So right, so here you can just put on this Mx and Z. So what this means? So you are releasing this reactions on X direction and the moment along X and Z direction, but not in Y direction. So the reactions are there. So this depends on which axis you are going to give your roller. Suppose I'm going to give a roller support here in this direction. So there is a different concept how I want to release there. So I will release there as Fy, not Fx. So please understand the concept. So when you go for that particular part where you are going to release, keep your axis of your roller support. With respect to that axis you need to release. If I'm going to keep a roller support in X direction, so this is your X directions. So I'll give as Fx and Mx and Mz. Suppose it's a Y direction inclined. So there I should change it. So it is not same for all the cases. So this case differ for where your support is fixed. So your support is in X direction or your support is in Y direction. So it depends on that. So Y direction means like some kind of gantry girders, some kind of cranes or movable cranes. So in such case they have in Y directions also. The roller supports will be in a Y directions. So they move in a vertical manner. So they need to release in that part. Or your bookshelves or some kind of racks or steel racks you are going to design, or movable steel racks you want to design. So in such case again, so you want to keep certain kind of hinges. So you go for pinned also. So it depends on the application where you're going to use it. And then the part is your multi-springs. So multilinear springs and your foundation springs. So especially you might be heard about a machine foundation or in your concrete technology lab, you might be seeing a table vibrator. So some table vibrator you see all four sides there is a spring attached to that. So when you start your vibrating machine, what happens? The table starts vibrating. So where these vibrations are going, one such simple example, to the springs. So the spring is taking your vibrations, all the springs is taking your vibrations. So there is a stiffness of spring is defined. So in such case, we go for multilinear spring or foundation part. Suppose your soil, somewhere you have a soil compactions or some kind of a dampers. So you need to give a spring for the mat foundations. So there we use the foundation parts. And especially inclined, so where you go for inclined, so where you have some kind of bracing element or some kind of stiffness method, that is your viscous damping or some kind of bracing, we can go for inclined method. So tension and compression zone is basically for compression only, where your soil is again relating to the soil only. So compressions of soils are happening. There we need to give up tensions or compressions. And next we are going to move for the load definitions, which you are going to quickly design. In the STAAD Pro, I'll directly go here. So first is vehicle definitions. So the vehicle definitions are given as per IRC 6, Indian Road Congress 6. So that is another separate code for bridge designs. So when you go for bridge designs, we have it. So you can see one sample example where the vehicle directions are moving. So you can see this part. So how to define it is, first you need to select the vehicle type. There are 4 major types which you have. Class AA tracked, Class AA wheeled, Class A and Class B. Under this, there are various types of values. Again, I will show you later on. So certain set of values are there. What is the load value for your Class A? or what is the axle load value. So some has 200, some has 350. So like this, various combinations are there. So according to that, we need to define the load values. And this width, which you see on the screen, you can see, I'll show you a sample model here. Once you go to general and load definitions, here you can see this vehicle definitions. When you click here, it asks you the distance. What is the distance of that part? So how you want to define that distance? What is the load value and basic distance? So that is the axle value. So from starting from first axle to rear axle. So imagine your truck, a big truck is there with 4 wheels. From the starting wheel, that is your 0, and to the rear wheel, back end, what is the distance? So we need to give that values. So front 2 axles. So when I talk about 2 axles, so 2 axle is like this. So this is called axle. So what is the weight of this part? So from here, it starts as a 0 and it goes to the backside axle. So second value. Imagine there is a different types of pressure values in the tire. So when you go for filling your air, so you see that pressure in the petrol pump. You see when you go with your parents or your father, or you take your bike, you go and fill your front tire and back tire. They used to adjust the pressure value, and they adjust the front wheel and back wheel with certain pressures. Yes, of course, in same case, we have different type of load pressures, which is going to be taken care in the vehicle directions. So according to the vehicle directions, we need to define that in the vehicle load definitions. So that's what I showed a small diagram here. And secondly, we are not discussing about the wind load. So wind load, a step-by-step procedure. So just I have shared you the highlights, what we need to consider as per 875 part 3. Right. So here are again the categories, how you want to bring your categories of buildings, how you want to bring this part. So finally, we want to bring this 0.6 into V square Z. So that is your wind pressure. So again, I'm showing you how to define the wind pressures. So just you can go here, you can see this part and you can find added, and then you need to give your wind pressure with respect to your height. So what you want to give. Again, certain cases, the students basically blindly give this part. So I have seen a number of students blindly just they give it as like this and they finish the work job. So you click it OK. They submit it. Then they will say factor as 1.5 or 1.2, whatever they think, they give it. Now, you can see this. Its height of the building is not more than that 3 meters. So how come you say that the wind intensity is given here? So it is basically wrong. So it is 12 meter height is showing. So don't do this kind of mistakes in exam also. So please take care of this. So we should not use this AC7. So how you want to do this calculation is with respect to height. So I showed that over here. So this is the table. So we need to do the interpolations for the values. So what is the height of the building? So you can see this clear height. So each zone has a different height. So let me show you in here. Yeah, this is the code book. So here you can see this part. So mostly you might be studied in your classes or in labs. So your teacher might be taught this, right? So here we have this set of values. Zone 1, yeah, this terrain heights. So with respect to height, we need to do the interpolations. And then we need to incorporate the values over there. So finally, we get the intensity and the height value. You should be taken care. And one more important thing, the data for India, it is more than 10 meters above the sea level. So we have the data about 10 meter height. So when you see some YouTube video, they give the wind pressure here also. You see some icons. So the lines will be coming here also. They blindly gives here all this part as wind. So it is not that. So if this is 3 meter height, okay, basically this is a 3 meter height. So don't give a wind pressure here. So no need of wind pressure 1.5 and this is 3 meters. Sorry, this is 1.5 and this is 3 meter. So no need to give this height 3 meter. It is less than 10 meter. Why? The reason is, so again, the code is saying that it is available only after 10 meter height. It is effective. So please take care of that important clauses which is given over here. So you can see this part. So basic wind speed for India, it's available after 10 meter height mean ground level. So adjacent buildings are already occupied by some other buildings. So you don't have such effect of wind at taking part in your building. So it is safe enough. But yes, but if you have some kind of tall structures like a 10-story building, G+6-story building, or 5-story building, then you can go for combinations and you can find out your wind values. Right. So finally, then we have discussed about your seismic. So these are the seismic inputs, and load combinations also have given to you. And very first day, student asked me, sir, I have facing some problem here in generate load. Some problems are coming. So how I want to avoid this error? So when you click on generates, so when you go for seismic, so let me show you that seismic. So when you click on seismic definition, add, and you select your Indian code. So 2005, you can go ahead, and here you can see this generate. So for first time when you click, there is an error. So you will not get this part in your software. So number of students reported I am not getting this part or issues. So this is nothing but the code book is not updated to the software. So there is a small issue in this part. So you can solve that part. I will share that also. So we have that material, how you want to do that. So let's see that for you. I have kept that error. Yeah, I have this part. So you can take this part. So how you want to solve that, I'll share this file later on. You just copy this link, what I have provided here. Just you copy this fully, hold together with including your quotations, right? So those who are having that problem, I will share this in your email IDs. You can take this. Just click on run. So you have a CMD command prompt. So you see CMD, type CMD and right click as run as administrator. So that is important. So please don't click simply CMD. So once you click simply, it will not take any effect. You can see this user, my laptop name will show here. So don't do that. So you can do that CMD command prompt, right click, run as administrator. So click that, you see Windows 32 file will come. You can see a Windows 32 file will be appearing. So this is the right procedure. So what you do, you just copy this fully. Just copy this Control-C and put it there and press enter. Just press enter. So you'll see this successfully it is updated. So that once it is done, just you can close it and you can come back to the STAAD Pro and you can open this and you will find the generate button is on. Fine. So I will explain you this error also. Later on, I'll share you that file also, right? So here you can see the city wise as well as zone wise, what is available, zone 4 values, all the data are incorporated here. So as we discussed about Omrf and SMRF, so two main important topic I'm discussing. So special moment resisting is some case of like where the seismic effect is very heavy, or I want to resist the frame element of more rigid or more connection to the seismic part. So I can go for SMRF. But in the same case, I am going to give a shear wall connection. So some shear wall or ductile detailing. So then I can go for a shear wall connection. So concrete ordinary shear wall connections or ductile shear wall connections. So you can see that also ductile shear wall connections, both. So you can use this when you design as a shear walls for a building. Suppose I want to make a shear wall here, so I can go for shear wall design also. But please excuse me, but ductile detailing is a different area. So that takes a different time slot for discussing on ductile detailing. It's a different, particular, totally different. So we need to think about that. Right. So we can use Omrf at present. So what are the values that will be coming there? And for hospital building, all important buildings, you can take 1.5. So factor. And soil data, whatever is available for you, and damping percentage, you should take 5%. So you can take 0.5% as a damping ratios. And this is your time period, TAX and TAZ. So what we calculated in the sheet that you need to add it here. So it's your dimension of the building. So for this, what I'm going to show is I have already done a model here. You can see this is a seismic building. So this is a complete seismic building. So here all the cases are added by myself. So you can see this part. So the self weight of the building. Now why we need to do a floor weight, and you can see here the roof load is not there. Roof live load is not there. So we should not allow any roof live load on seismic model under seismic definition. Make my word clearly. When you are dealing in seismic definition, seismic live load should not apply. The code say that is 0. So we are not considering live load as for your seismic inputs. Right. What is the reason for it? So the reason is, so whenever you get a seismic or some, what is that called, a vibration, that is a seismic effect or earthquake, do anyone go and stand on the terrace for saving yourself? Do you know that seismic is going to come to the building? So this building is going to collapse. In such case, your people are, you say all the peoples are saved at the terrace level? No, right? So it is not safe to hostage or rescue people from the terrace level. So in such case, that is the reason we are not consider any live load consideration on the terrace level. So the terrace level live loads is 0 when you define your seismic inputs. Second thing, whatever the member load, whatever the load value you consider for a brick wall, the equivalent opposite load should be given. The reason again behind here is the seismic is a base shear concept. So what is happening here? So whatever the seismic weight is coming towards the gravity. So this is, say, suppose this is a ground and this is your seismic weight, right? So the vibration should be balanced. So the gravity load, whichever is going to come fall here to the building structure, it should be balanced with the seismic force. So whatever the load of the building structure, the same equivalent amount of seismic input should be given to the ground. Got it? So that's what we say this as minus, wherever you give the brick wall load, minus 13.1 kilonewton, whatever the loads we discussed yesterday. So we put a minus due to against the gravity. But here in the seismic definition, when you give, this should be in opposite directions. So we give it as plus 13.1 kilonewton per meter. So we are balancing that. So that finally we call a base shear concept, VB. So what is happening to the building? So what is your base shear? So it is equal or not. If it is not coinciding, your model is failed. If it is coinciding and it is within the limit, safe. So that's your seismic analysis. So that we give here with positive signs. Whatever you see here, it is 13.1. For which beams I selected, for the same beams I can do it. So same way for the wherever the openings are there. So same beams have the same load, but in the opposite sign. Now similarly for the floor dead loads, wherever the floor dead loads you are given 0 to 6 level up to here, it's floor. So floor, floor, floor. But roof dead load is there, right? So roof dead load is there. So where it is at this part. So next, seismic weight of the building. So once this definition is done, then you go for load case detail. So you can go for load case detail. So you can start with your seismic inputs. So you need to start with 4 basic input: X positive, X negative, Z positive, Z negative. So to do that, you can click on add button and go here to seismic. So you can add in X and Z, not in Y direction. So we are not considering in the building height. So we are not take this Y directions. So you need to take the factor 1 for positive X. Negative means negative 1 for X directions. So like this, we need to define the values over there. So whatever the values you are giving, you need to give it. And then finally, you need to see for Z direction also. And finally, dead loads, whatever you calculated, self weights, floor load, all you give, live loads, everything you can give here. Now, load combination, as I showed you 1.5 dead loads. So this combination is created here, right? So how to do the load combination? So click on load case detail, click on add button. So I have already shared this file in day 2 also with numbers. So you can see this define combinations. So here you need to type the name, what are the names you are going to give. So that 1.2 or 0.9 value, suppose I need 0.9 dead load only. So I can give this factor as 0.9. Now you can see this SRSS and ABS method. So this is some kind of a linear and non-linear method for time history method and response spectrum method. So square root method and absolute modulus method we have. So no need to touch that at present for the beginner level. So you can click on normal combinations and whatever the load factor you want to give, you can give for 0.9 and select the dead load you just put this on other side. So it will get added to your structure. Now, when you find out the load auto load combination, you can see this auto load combination. So why I'm not doing this basically is here you can see some kind of code, directly Indian code. What are the value you have? It shows your structure, steel structure or plastic structure, what are the structures available. You click generate loads, it combines around 25 C, as I said, 27 combination it creates. So you should understand what is this combination basically. So 51.506150, what is that basically? So please understand and do, then it is okay. Now I want to repeat this cycle for certain repetition of load. So suppose I have a time second 0.1, 0.2. So I can click on repeat. Click on repeat load. So for 0.1 second, 0.2 second, 0.3 seconds. So such kind of analysis I'm doing. Then I can click on repeat load. Then it get added on the structure. You can see that. So everything will be added over here. So what is this 1.5, 4 minus 1.5? 5 means the case, the dead load case which you created. 5 means your dead load case, what you created. So dead load case is your dead load. So dead load multiply with 1.2. So sixth load is your live load. So live load into 1.2. Second, X negative. So this is combinations. So it is taking as dead load 1.2, live load 1.2, seismic negative 1.2. So please don't do this. So the shortcut to delete this file. So please don't go and delete one by one, delete here. Just open your STAAD editor. You can edit from there directly. So open STAAD editor, whichever the load case you're not required. So select that load generation directly fully from here and then delete it. Right up to this road repeat. So delete that. Right. Save the file and close it. So you'll get your back file. So this is how we do it and we get your file retrieved. Right. So I'm just stopping here for the day and we'll go further for this part. And let me stop sharing my screen. Yes. So already I said, please give your feedbacks. So that is considered as your part of attendance as well as for your certifications. So please give your feedback. I'm sharing the link right now. You can go ahead. You can give your feedbacks right now. Okay. So let's come for the questions. What are the questions for the day today? Yes, Santosh, the recorded session, all the recorded videos are available in school page, Facebook page. It will be updated after 1 day. You can go and check in our school web page. School Facebook page. It is available. Day 1 and day 2 recorded video is available. Santosh, you can go there. You can check it. And okay, fine. Next, building plan of this presentation. Okay, this model. I can share you the model plan. I don't have, sorry to say, I can share you this model. You can have for a reference part. Okay, next. Okay, I'll put it in zip file. You can unzip the file and you can access the files there, right? Maximum range of Omrf value is 3. So, iteration value. So that is 3 is your value of iteration response spectrum. Okay, please discuss again about VB positive in opposite direction. VB positive, what is that? Suraj Kumar Gupta, I'm not getting your question. VP positive in opposite.
So that base shear concept that you said, in opposite direction you have to give.
Okay, fine. I'm coming to that. I got it. Okay, sure. Then any other questions? Okay, any other? It is available throughout. So the recorded session will be available on Facebook throughout. You can check it there. Okay. You can't take, Hussein, you can't take less than 3 value. Designing parking lot or garage, do have to define a vehicle load, or can simply, no need to assign any vehicle load. Yuvraj, it is a normal slab portion. You're defining only for a parking slot. So no need to assign any vehicle load there. So vehicle load is considered when you go for bridge design. So when you go for some bridge consideration or bridge design, we need a load, vehicle load combinations there. So moving loads. That can be done also using your ILD method, influence line method. We can use that. For parking in your home or parking in a restaurant or in a shopping complex, no need of vehicle loads. Just assign the slab load, dead load weight of the vehicle. What are the maximum? Normally you're going to park only a car. So that can be less than 300 or 200 kilonewton, not more than that. So just you can go for that. Okay, why earthquake and wind acting simultaneously in combination? If you want to, Manjunath, question is earthquake and wind load acting simultaneously in combination. Yes, we can do it in a model for both seismic and wind load combination. In the earlier, older version, it is not possible. In V8i and a Connect edition, it is possible. We can combine both. But the reason is complication of the results, how you match the results. So we use some kind of Excel and we need to filter out the results. So which combination is going to have a worst effect? So that is the reason we don't combine the models together. So we have seen if a seismic effect is higher in that particular zone, then we go for seismic design, or wind effect, then we can go ahead. But for studies purpose, we can combine the model and you can get your data, no issues. Okay, what is the reference load for equivalent static analysis? See, reference load basically come for some kind of angles when you have certain kind of inclinations or some kind of load analysis for the building. So there we can add a reference load as well as the reference load combination, which I can explain you here. It's on the part. So some kind of truss buildings are there. Suppose you have this is a ground level and this is your roof level. Suppose I have some kind of inclined roofs. Okay, some kind of roof sheds like this. So I want to add certain loads to this reference points. So in such case, I can create some reference points. What are the loads I want to assign to this particular joints? I can go for it. And Suraj Kumar Gupta question is on positive and negative. So the concept of positive and negative is the total weight of the building. Weight of building that we call it as a mass, lump sum mass. We call it as a mass of the building. So total mass, what is the weight of the building? So when you compare that, so equal and opposite force, whatever the base shear is coming, so this is a building weight. So this is negative due to the gravity, it is falling downward to the ground. And this is your, imagine your seismic weight, which is you're going to balance this. So it should be in a positive. So this both should be equal to balance the forces. So that is called base shear. So wherever the base shear is coming, so this is your foundation. So what happened? So your foundation should get the equivalent amount. If one is overloading other, suppose this load is higher or this load is higher, so there will be a failure. So there will be a failure. So only the seismic value, we cannot do it in one go. We need to do the iterations. We need to do the iteration at what time second your base shear is matching, at what time period of acceleration your base shear is matching to the frequency. So we have response spectrum, time history analysis, and one more, that is another one is called what is that? SRSS method, CABS method, or CQC method. Various methods are there. So we can go for these combinations and we can do the iteration process. So for that purpose, we define that as a negative and positives. Okay. Any other questions? Okay. How is moment? Okay. One second. I'll come through order. Azad Rahman, before release moment, it shows lesser moment for mid section, but after releasing, it shows higher value in the section. Why? Please ensure that beam is single beam or not. So as I already said, so please see that beam which you are making a connection. So this beam has a single element. So if this beam has a single element and this is a second element and you're releasing here, so that doesn't have an effect. So this should be a continuous beam. No column should be ignored. It should be a continuous beam. So you may ignore this column, then you release this part, it will be affected. As I showed in the model, you can see these mistakes. See, single beam, and you're making a moment release. The moment will be there. It will be present there. It will not go zero. Okay, so make sure you are doing properly the beam node selections. And yesterday also, Suraj, I guess someone asked me that node is not coming. I'll come to that part also. Just I got remember that one question. Keep it in hold. And sir, for multi-story parking structures, vehicle will also be parked at roof. So it will be, will the live load be considered in season? Yes, in such case we need to do. That's what I'm saying. For normal parking area, ground level parking, wherever the slabs just you are going to do, there is no need of vehicle loads. But multi-level parking, you are asking about multi-level parking now. So this is like G+6 or G+7. Then you need to consider. But even though for roof level, the live load is not considered. For parking, it is okay. But roof level parking, that is your terrace level, it should be zero. So that is not considered as a live load. So parking building will be separate part, how you do for analysis part. So it's only for parking of your vehicles, not for humans or some kind of part, right? Okay, Sandeep Kumar has, Sandeep, the moment release as it is required moment distribution method, theory or automatically detected by STAAD Pro. Moment distribution method only, that is called redistribution of moment. The concept of behind that is redistribution of moment, how you want to distribute your moments for the members. Okay, Hardik asked another question, how it's moment released for secondary beam in actual construction site. In actual construction site, it depends on the rebar, how your rebars are defined. So where your rebars are designed and connected, so that will take care of your secondary moment. So in some case, you see the rebar where they bind the rebars like this. So they keep the rebars for the section like this. So this will have only two bars running, like two parallel bars, tops, sorry. You can see, take in 3D. So at what level you are going to do the anchoring part, that will take care of your secondary moment. If no anchoring is provided, some kind of a crank rod, say they provide as a crank rod, so it will be like shape of this part. So we need to design as a crank rod, this shape. So that will take care of your moment distributions. So that comes in RCC design. Okay, fine. Any other questions? For seismic analysis, we need to give balance force. What is the balance force for all wall load? Balance force means what? I'm not getting, Suraj. Again, balance force means you want to balance the forces or all the dead loads. Basic concept.
No, sir, as in design, you defined the positive load that I talked before, na, for the seismic. For balancing. So if we are designing a building for seismic analysis, then is it required to do that thing? That
yes, of course. Whatever the model you have, you need to do that.
Okay. So is it possible that you can share that STAAD file?
Okay, I will put it in zip file. Okay, it will be in a zip folder. You can unzip and you can use that.
Thank you.
Perform analysis page in all options. Okay, just a minute. So let's take that. So perform analysis. When you go to STAAD Pro, here go to analysis. This part you're asking about, this part, I guess. So here there are a number of part of non-linear analysis, cable analysis, P delta analysis, all the higher level, all part of analysis are available. So in perform analysis, when I want to know only the static load, suppose a dead load combination live load, so then simply I can go for static load check or load combinations, static check only. So static load. So we can go for static check and static loads. But if I want to know the mode shape, suppose see in my model I have created a mode shapes. You can see on this model. Let me run it because I deleted some file. Yeah, fine. So now you see in this model I have added a mode shape also. So when the building is getting some kind of seismic vibrations, so it's having a 6 mode shapes are here. So we can add 12 also. So how this is going to behave? So basically the mode shapes, you can go and check in here. You can reduce this value and you can see how this building is going to behave in different combinations of loads, or what is the possibility the building is going to get collapse, right? So this you can go ahead, you can add that. So for that also we go for perform analysis. For that, to get this part, so you need to add one extra factor in the dead loads. So go to dead load. You need to add this model calculations. So this model calculation is your eigenvalue. So we call it as an eigenvalue. So what is the mode shape is coming for the building? So it is calculated from your eigenvalue, mass matrix, stiffness of the building, and then we calculate your eigenvalues. So to do that, we need to go for dead loads. We add this release method, last one, model calculation. So this will help you to calculate the frequency, how the building is going to vibrate and how it's going to behave in mode shape. So if you add that, you get your building done. So once you go for post processing and then you see this beam displacements, you can see this in a animation also. So mode shape, apply. So what are the possibility the building is going to have behaving? So that we can discuss over here. Right. Certain case there is a concept re-entering corners where some kind of connections with ductile building that can be taken care of. Right. Fine. So any other last questions for the day? Okay. Thank you.
Sir.
Yes, Hardik.
This is Hardik. Sir, I want to clarification on that multi-story parking question. So you're saying if the vehicle is parked on the top floor, that's the roof. So would we consider it as a live load in case of a seismic definition?
Dead load, dead load.
Okay, as a dead load.
Yes.
Okay. Okay.
Yeah.
That's it. Thank you, sir.
Yeah. Thank you. Okay, so we will close the session and meet you tomorrow for a basic design concept that will be discussed tomorrow. Fine. Thank you for all.